Okay, so iterator 2, of course, is pointing to a pair, right? So if this let me, it's just because it's kind of bothers me, I will say if iterator 2 indeed does not equal pairs and, which means that it did find something, right? So then print hello 1 2 3. All right, so iterator 2 is pointing to a pair, so this should be iterator. See, this is like a pointer to my pair. If I want to talk to my pair, I need to either dereference the iterator just like this, and say then first, which is hello, and then also I need to say dereference the iterator, iterator 2, right, and say second. That should together print hello 1 2 3, because this is a string and this is an integer, because this is how this pair was created. It's a pair of an integer and a string, and when you create it, like we created this str int pair, its first element is hello, its second element is 1 2 3. Okay, and since I'm using hello and 1 2 3 all the time, so this is what should work. And I really don't want to print anymore, so I just say return 0, right? Kind of stop it right there. So let me see if I run this. If I run this, see what happens. So hello 1 2 3. Okay, so this is the only thing that we print. And let's print new line as well. Okay, so let's print the new line. Okay. Now again, recall that with objects it's advisable to switch to another friendlier syntax, which is this. So instead of doing this, just say iterator 2 pointer to member dereference. Most people will prefer this syntax. Okay, so because iterator is an object, but it behaves as a pointer, so it actually overloads pointer to member dereference operator, and it knows how to essentially use itself when as a pointer to an object, in our case of type pair, right, defined like this. And of course inside that pair, when you use iterator as a pointer, it pretends to behave like a pointer and overloads all these operators. And so you can say, okay, what's in the first element of my pair and what's in the second, right? So this all came back from here when we're trying to use this. And I would, when I'm looking at this, I think that again, because this is sort of like a layer on top of existing code, when I wrote this, I think this will not work properly, because it says P first, P second. It's like first I need to, for this to work properly, I need to, there's no P. It's a syntax error in this example. What it should be doing is something like this, using this iterator and using something like that, or something like this to access element. Well, alternatively, what I could do would be this. Pair, right, pair. A reference and initialize it with dereference iterator 2. Pair, my pair. equals so create a reference to this object, but object is pointed by the helper iterator object, which behaves like a pointer. To be able to remember, when you want to create a reference and you want to initialize that reference, and you have to initialize your references, then you take the pointer and dereference it, and this all should work. Then I can do this, right? And I can rewrite this statement by saying it this way: my pair first, and then my pair second. It's essentially, it's doing exactly the same thing, but I just wanted you to show that oftentimes you will see this in the code where those things are done casually. You need to essentially be able to teach yourself how to calm down when you see something like that and your blood pressure, you know, goes up. Well, I tell you, if I see this statement, of course, before I become completely comfortable with this, I really need to investigate what type of object is this, and eventually I'll find out, oh, it's an iterator to object such and such. Okay, what is this then? Well, again, I need to investigate. It's not like I instantly become comfortable with this statement. I still need to be able to understand what this is and what this is. And then I say, okay, sure, it seems like if this iterator has an overloaded dereference operator, it returns back an object. This object can be used very successfully to initialize a reference to the same type as that object is. So, you know, again, I apologize for this kind of, you know, cryptic part of it, but at least we say that you can do those things with iterators. Okay, you can dereference them, and they become an actual thing. But here, you know, I could do just this without the reference, and then I'm making a copy, right? But I really don't want to make a copy. My container already has that, so why create a copy? Just say it's a reference. Don't create a copy. Just my pair is a reference to something already stored in this container, and I was able to populate. Well, anyway, some of the syntax, perhaps it may be helpful if you watch this video at some point and refresh your memory. Let's just move on to other examples. And I sort of like jump to the find algorithm example here, hoping that this will be a very simple example, which we already saw, but the pair got in the way. But guess what? Our conversation about pair is going to be very, very helpful. Everything we mentioned today, when we start to start talking about the associative containers, and they use pairs extensively because they use pairs of keys and values and provide direct access to values through these keys. And so therefore this is very, very appropriate that we mention this. So algorithms such as count simply, you know, take this vector of strings, and I'm pretending that I'm calling this vector. Look how this function f takes a reference to a vector of strings. So vector of strings was populated elsewhere, function was called, and this is the content of the vector that I get. So I say count every occurrence of the word C in it. So there you go, it just goes and returns the counter variable, and it says, all right, C can be found 2 times in this container. All right, so just another algorithm which is available when you go and when you include this algorithm header. All of this, you can basically, we can go back to C++ reference page and say, you know, algorithm, right, and search for it. And as we hit the header, it will tell you, oh, okay, so these are all kinds of things that you can do generically because they're already defined. you know, you don't have to like sort, right? Like sort. We already saw that sorting of fruit, right? So there's all kind of types of things that come with those algorithms, and they you know, you need to occasionally check this list and see if what you're trying to write manually already can be prepackaged here. It's totally impossible to avoid writing things by hand, but oftentimes, remember, using an algorithm is one line of code with no bugs, right? Whereas writing your own code with 15 lines of code could introduce some really nasty bugs. So finding an appropriate algorithm can be good thing to good direction. All right. So there's whole family of finds. Find if some condition, find if not some condition, find the ending, find first off, and things like that. Adjacent find, like find elements that may be next to one another, and things like that. So it's very resourceful, right?